Hello everyone, welcome back to Easy Engineering. I'm Gervais as usual. Today's session we are going to see how you can install 4 cylinders in parallel connection with a rope of wrap volt. So let's be quick. As usual, you open your wrap volt, then you come over the equipments. You take hydraulic equipment as our concern, then take work surface so as you have where to put our cylinders. So as we have said, we are going to make a circuit of composed of 4 cylinders, so you have to pick cylinders. It does take double acting cylinders. So take 4 cylinder as like this one. As you can see, I'm taking 4 cylinders. So in order to be able to connect those cylinders in a parallel circuit, we will need input manifold and exhaust manifold. So we come over there, equipments, hydraulic equipments, select manifolds. It does pick 5 ports fixed manifold. As I've said, we will need 2 manifold, so let me take another manifold here. Five ports manifold. As we know, you have to put also pump unity, so bring pump unity, then fix it here, and bring DCV to control all those cylinders in at the same time. Bring DCV valves, then let us take lever operate the DCV. So as you can see here, we are having all the equipments we are going to use. So now we are going to install it. What do we mean by parallel circuit? When we say a circuit is parallel, it means it is independent to each other. It means one can work, other is while other is not working. So it means it will have its own input and its own output. So let us take this manifold as one for input and another for output. So to supply this manifold, we should have the cables from this DCV. So because we are having this DCV which is going to control all those cylinders at the same time. So what do we say? For as usual, as you know, here for DCV, A port is for input. It means A port supply the end cap port for top dead center, bottom dead center, sorry, of the cylinder. So we have to take this A port and connect this with the input manifold, and B port make it to the exhaust manifold. As you can see here, we are having two supply. It means input supply and output supply. Each and every cylinder here is going to have a supply from input and supply from output manifold. So let's supply this first cylinder. Take input supply. The second cylinder, take the input supply. Third one, let's take input supply. Then the fourth one, let's take input supply. So as you can see here, we're supplying input for each and every cylinders. So as let's take differentiation colors so as to allow this cable not being so challenging. Let us paint this input supply with red color. Let's paint red, this one, red, and red. So as you can see here, we are going to supply output for each and every cylinder. Supply output here, output here, and output here, another one, here, and the other ones should be supplied to. So here, as you can see, we have supplied all input and output. So let us paint these cables, or these cables of output with green color. Let's take green color, green color. So we are done. Let us supply the cables from the pump unity to go from pump unity. As you know, let us connect tank to the tank port from the pump. Take this one. Let me take this one for a better view. This one, as you see here, we are having pressure port, supply pressure port of the pump. Let's paint this one too. Pressure port, let's paint red one, and return port, it has paint green. So we are done. We are going to simulate this one, so as you can see what's going on there. So let me make cutaway view for each type of components to see what is going on inside there. Let's take this cutaway view of this CV. Let's take cutaway view of this cylinder. This one. Cutaway view of the second cylinder. Cutaway view of the third cylinder. Cutaway view of the third one, the fourth one. This is we are making cutaway view for seeing what is happening there. So let us learn. As you can see here, when we land, we have to switch on the pump. So the oil is coming from the pump to the system, reaching to the DCV, but because we are in on off position, the oil is not having the way to pass to the system, to the manifolds. So the oil is automatically going back to the tank with the help of relief valve. So let's make cutaway view for this manifold too. That will help us to understand more. As you can see, this is output manifold. To make cutaway view, this output manifold. As you can see, you can move the lever so as to raise all those DCVs up and down. So let's do so. When we are raising up DCV, you see, as you can see here from the graph, the oil is coming from the tank, from the pump, then they reaching to the DCV, and then by operating the lever of DCV, you are allowing the oil to go to the manifolds. So each and every manifold is supplying the cylinder. So for lowering the piston, it means we are just supplying the oil through output manifold, so as each cable which is connected to this output manifold is going to be supplied with the oil. And then, as you can see here, this circuit is very versatile, or it is very strong compared to the circuit which is connected in series, because as you have seen in series circuit, all cylinders do not reach to the top dead center, because the output of one cylinder is input of another one, and the oil which is containing here on output or on this ball of the cylinder is not capable of just pressurizing the second cylinder to the top dead center. But for here in parallel, as you can see, all cylinders reach to the top dead center at the same time. See here. So this parallel connection will be very versatile and will be very good, and it will be just supplying very high energy compared to series circuit. So thank you for watching. Next time we shall be studying on how we can just use DCV of solenoid operated, which will just include some more electrical circuits and everything. So thank you for watching. See you next time.